Hi there, Esther. I still made this video for you, and I'm hoping your quiz gets delayed by a single day since you had school off today. I tried to take all the topics you mentioned and shove them into a single video rather than sending you a collection of 6 45-minute videos, which I know you can't watch. So I'm going to shrink this down and go as fast as I can and get all the topics you mentioned hopefully done in under an hour. So I really hope you were able to get these pages printed. And if not, get a piece of binder paper, and I'm going to go as quickly as I can. Just to give you an overview of the topics. First, we're going to talk about the equation of a circle. And equations of circles are really easy to work with, very easy to work with. Then we're going to talk about the area of bases, how to find the volume of solids such as prisms, cylinders, pyramids, and cones, how to find the surface area of prisms, pyramids, cylinders, and cones. And then I got you some practice problems for all of those. And the last you mentioned nets, so the last 2 pages are nets. So I'm really hoping you were able to get this printed because it'll make it a lot easier. Okay, I'm going to make this as simple as possible. Okay, step number 1, we have an equation of a circle here. And first we're going to do the definition of a circle. So the definition of a circle is right here. It's a set of all points which are equal distance from a single point. Now I'm going to say this definition and I'm going to draw on the image at the same time. Watch what I draw carefully. A circle is the set of all points which are equal distance from a single point. A circle is the set of all points which are equal distance from a single point. When you say the word distance, you're going to notice what you actually draw is the radius of a circle. So the circle equation is based off the distance equation. So if I had 2 points, okay, if I had a point here on the circle, we'll just call it XY, and then a point here, we'll call that XY from a single point. The distance equation here would be, and we wanted to find the distance, we'd say distance equals giant square root, subtract the x's squared, subtract the y's squared. Hopefully you've seen that before. But we're going to clean this up in 2 specific ways. One, since it's a special point, that center point, we have a special set of variables. We call the XY coordinate of the center of a circle H and K. So remember when I said the distance is replaced with radius? So that distance is x minus, if we went this way, h, parentheses squared, y minus k, parentheses squared. Remember the center of the circle we label hk. So far we have this, that the length of this radius equals the square root, using the distance equation, x minus h squared, y minus k squared. But we really don't like to work with giant square roots in equations. It makes them awkward. So to do that, to get rid of that, we square both sides. So I take that radius equals, it's an equal sign, x minus h, parentheses squared, y minus k, parentheses squared. And to get rid of that square root, I simply square both sides. So the final version is going to be this. Usually we put just swap it around. So we're going to go x minus h, parentheses squared, y minus k, parentheses squared, equals, because we square both sides, radius squared. This is the equation of a circle. Okay? Just like the primary equation for a line is y equals mx plus b. That's the equation of a line, the y-intercept equation of a line. This is the equation of a circle. So when they ask for an equation of a circle, that's the first step. Now there's 3 things you need to be able to do with an equation of a circle. You need to be able to build an equation, pull it apart, and graph. Build, pull apart, graph. We're going to do a couple of each. Okay, to build an equation of a circle, there's only 2 things you need. You need a center, and you need a radius. There's only 2 things you need for an equation of a circle. You need a center and a radius. Only 2 things. You need a center, an HK, and a radius. Keep that in mind. Okay. It says, write an equation of a circle with a center of -3, 0, and a radius of 2, -7. So we want the equation of a circle. And let's just draw our circle just for visual sake. Our center is -3 and 0. And the length of our radius is 2√7. So we're going to build this equation. First things first, you simply write the equation. X minus h squared y plus y minus k squared equals radius squared. So now we have our equation. Now we're going to plug stuff in and clean it up. This is your h. You want to circle the -3, and we're going to plunk it right in there. Just put it right there. Do nothing with it. Just put it right underneath where h is. This is our k. Put a little arrow. We're going to plunk it in right there, 0. And we're told our radius goes right there, 2√7. Now, pull down the equation around it. X minus -3 plus y minus 0 squared equals 2√7 squared. Last but not least, what's called clean it up. Clean it up is not hard. The simple thing of clean up, you watch out for double negatives. Watch out for that 0. Let me show you what I mean. X minus -3 simply becomes, double negative makes a positive. So it's x plus 3 parentheses squared. Y minus nothing is just y. So y minus 0 is just going to be y squared. Now, whenever you have an exponents with radicals, I would pull it aside and do the math in the margin. So we're going to go 2√7 times 2√7 in the margin. We multiply outies, multiply innies. There should be a 7 there. 2 times 2, of course, is 4. √7 times √7 is just 7. Technically, it's √49, but that's a perfect square. So I'm not going to write √49. I'm just going to go straight for the √7. So 4 times 7, our final answer when we square this number is 28. And that, my dear, is building an equation of a circle. Now, pulling apart is even easier. So you start with an equation of a circle. Step 1, you write the original equation right underneath it. X minus h, parentheses squared, y minus k, parentheses squared, equals radius squared. Okay, now watch very carefully. You just ask yourself, in this scenario, what would your h be? What would your k be? And what would your radius be? I'm going to give you like 20 seconds and have you just flat out guess if you need to. What's the h, the k, and the radius, Esther? Just take a moment, flat out guess. Okay, let's check here. Notice the sign swap. So your original h had to have been -2. The sign did not swap. It stayed the same. So original k had to have been +5. And if r squared equals 49 square root, your radius is therefore 7. That is how you pull apart an equation of a circle. Last but not least, graphing an equation of a circle, which involves pulling it apart. So if I wanted to I love graphing circles, by the way. They're so easy compared to lines and worrying about slope and the intercept. Circles are so much easier. Let me show you. You start by writing the original equation. Now, pull out your HK, which is your center, and your radius. So I see my center here has to be -5, +3, radius of 4. So I start by plotting that center point. Make sure you always label your centers. There's your center point. Now, your radius is 4. So from that center point, go up 4. Go east 4. South 4, west 4. Honestly, the hardest part of circles is making it kind of look like a circle. Ta-da! Easy peasy lemon squeezy. Here's another one. You start by, again, pulling out what would your h, your k be, and the radius. The signs didn't swap, so that means h was positive. There's nothing there for k because there's nothing there. It's a 0. Wow, that's a bad 0. Let's try that again. 0. And, of course, your radius is 5 because r squared is 25. So now you graph 5, 0. From that point, we're going up 5, to the right 5, down 5, left 5. And that, my dear, is how you graph circles. So just to recap, okay, we got our equation of a circle here, and then we build an equation, we pulled it apart, and we graphed. Okay, now comes solids. When you're working with solids, particularly prisms and cylinders, okay, prisms and cylinders. Well, I'm going to be talking about specifically just for a moment about prisms and cylinders. In all the equations for prisms and cylinders, when I say the word base, I'm going to be using a capital letter. When I use a capital letter, when I say the word base, it always means area of a base. So in all the next equations, a capital B means area of the base. Now, when you're dealing with prisms and cylinders, you want to watch out how to find the bases. It can be actually a little trickier than you realize. Think CPR. CPR. In prisms and cylinders, there's exactly, the bases are congruent shapes. Those two congruent shapes are parallel. And those two congruent shapes are connected by nothing but rectangles. So when I say the word base in a prism and a cylinder only, there's two of them. There's two of them and they're congruent. They're parallel and they're connected by rectangles. Two of them. Congruent, parallel, connected by rectangles. CPR. So watch out for the bases. In fact, what I recommend you do first is always when you see a prism or cylinder, lightly shade the bases so you immediately identify them. Base does not mean bottom. Super important. So I'm going to, in the things below, I'm going to shade the bases, and you're going to notice that all of these bases, there's two of them, they're congruent, they are parallel, and they're connected by rectangles. CPR. Congruent, two of them, parallel, connected by rectangles. Let's lightly shade them. So in this regular pentagonal prism, this and this would be your bases. In a trapezoidal prism, this and that. Again, base does not mean bottom. Base does not mean bottom. So that red, this red right here that I just shaded, that is not a base. Bases, there's two of them, they're congruent, they're parallel, they're connected by rectangles. Alrighty, so top and bottom are the bases, left and right here, here. These, let me keep my colors straight here. These would be the bases. Now, why isn't the rectangles on the side? Because there's four congruent rectangles. The bases, there's two of them. They're congruent, they're parallel, they're connected by rectangles. In this cylinder, the bases are the front and back circle. Here, the bases are triangles. Now, super important, on the next page, when I write capital B, that capital B always means the area equation of that base, which changes depending on the shape. That's super important. You understand that on the next page. The idea of base always means area of. So capital B. So I'm going to go over these area equations. I'm not sure what you have or haven't covered in your class. Okay. If I have a regular pentagonal prism, the area of this base, I'm just going to reshade it. That shape right there, that's a regular pentagon. How do I find the area here? You trace the perimeter times the apothem, which goes from the midpoint to the center. That's a right angle and a midpoint. That's the apothem or apothem, depending on how your teacher pronounces it. Perimeter times apothem over 2. So if I wanted to find the area of that base, I trace around the perimeter times the apothem over 2. If I have a trapezoidal base, the area of this shape is the average of these parallel sides. So the average of the parallel sides, and we call that the base of the trapezoid. Watch carefully, I'm using lowercase b plus lowercase b. That's the parallel bases of a trapezoid. So I'm only getting the area of that shape right here. I'm going to shade it, only the area. Base over 2, you find the average, and then the height of the trapezoid would be at a right angle. So that's the area of the trapezoid. If I'm finding the area of this base, you simply do length times width. Length times width. Of course. If I'm finding the area of this base right here, this circle, that is pi r squared. So you get your radius, you find your radius pi r squared. Now, if I'm finding the base of this right triangular prism, there's a couple ways you do triangles. If it's a right triangle, you simply take one leg and you times it by the other leg over 2. That is the area of a right triangle. Leg times leg over 2. And if it's a acute triangle, it would be base times the height of the triangle over 2. Base times height over 2. This is a lot of information, Esther. A ton. And honestly, in my class, what I'm trying to go through in these 45 minutes is nearly 4 lessons. So I know I'm going fast. I may be able, if you don't have your quiz on Thursday, I may be able to talk with you live a little bit on Thursday afternoon around 4 o'clock your time if you'd like. Okay, now keep in mind, everything I have here is simply the equation for the idea of the base of a solid, capital B, because you need that for volume. Now, volume is a super easy equation for prisms and cylinders. Okay, watch. Okay, so volume, if I wanted to find the volume of this triangular prism, I'd start by finding the volume, the area of the base, and then the only thing that changes is a height. Do you see that? If I want the volume of a prism, this also works for a cylinder. I simply find the area of the base times the height. Again, volume of a prism and a cylinder, area of the base times the height. Area of the base times the height. So these are your volume equations. A cylinder and a prism have the same equation. So here would your bases be. And then you find the area of one base, the area of one base, whatever it is, whatever shape it is, and that capital B could be any one of these. The area of that base times height. That's it. And height is distance between the bases. Super important you understand that. In a solid, height is distance between the bases. It does not mean vertical all the time. Notice there's the front and back base. My height is distance between the bases. The equation for a cylinder is exactly the same thing. I find the area of one base times the height, which is distance between the bases. Distance between the bases. Now for a pyramid, you're losing volume because now you only have one base and you come to a point. Volume. And so what happens to your volume? You lose volume. Now you find the area of one base times height. And in this case, super important you understand this. When I use height here, it's height on the inside of the shape. Like you just drop it straight down at a right angle. Base times height. But then you divide by 3 because you're losing volume because you're coming to a point. For a cone, same thing. You find the area of that base times height. And when I say height, it drops down straight down the middle over 3. And again, you're losing volume when you come to a point. That's why it's divisible by 3. There's a more complicated explanation, but I'm just going to tell you what it is. I'm not going to explain it for time's sake, but volume of pyramids and cones are base times height over 3. Now that's volume. Volume is the idea is if I filled these solids with water, how much water would you get on the inside? That's volume. Not to be confused with surface area. Surface area is if these various solids had wrapping paper on the outside and you were to unfold the wrapping paper, what would it look like and what's the area? This gets a little bit more complicated. Now in my class, notice I tell people to actually fold it. This is called a net, but we're just going to have to do this using your imagination, my dear. Okay. So imagine if this flat pattern was folded back into a solid. What would it look like? See that flat pattern? Imagine it's like wrapping paper. If you were to fold it back into a solid, you see that it end up being a triangular prism. So let's kind of draw it right here. Put a dot there, and anything that you can't physically see when you draw solids, you do a dotted line. Okay? So on the left, this is called a net. On the right, this is the solid. Now, there's 2 ways to do surface area. One is you simply take the solid, you unfold it, and then you individually find the area of each of the pieces. So you would find this rectangle, then this rectangle, then this rectangle, then you'd find the area of this triangle and the area of this triangle. And then you'd add it all together. That's one way to do it. That's called using a net. I'm going to give you an equation for shortcut. Now, if this shortcut confuses you, forget it. Just unfold the shape and find each individually. Okay, we will do an example. So here's the shortcut. We know in this case, the area of the rectangle would be the area of the base times the height. So that would be base times height. This would be base times height. This would be base times height. So if you look really carefully, every time I traced base, look, see that? Let me trace it right here. When you fold that back up, technically what you're tracing is the perimeter of the base. So the first step is to simply find the perimeter of the base, which when you unfold it would be these three lengths. So the perimeter of the base times the one height, which is the distance between the bases. So perimeter times height plus the area of the two bases. Now notice, whoops, I should have shaded that a different color so it's easy to keep track of. We'll make that green, the area of the bases. Actually, nope, we'll make it blue because I already have perimeter as green. So area of the bases. Now remember, when I do 2, capital B, that capital B always means area of the base. So perimeter times height plus 2 bases. That is the surface area of any prism. Perimeter times height plus the area of 2 bases. Now a cylinder is almost exactly the same. Notice I said almost. So here's the net of your cylinder. If you unfold a cylinder, it looks like this. So if you were to draw it back, here is your cylinder. So if I wanted to find the area of this portion, it would be this base, right? Because it's a rectangle times height. But watch very, very carefully. This is a little hard to see, but use your imagination. Okay? This length here, when you fold it back on the can, is technically the same length as going around the can. Going around the can. That length of that rectangle, if you unfold it, is the same length as going around the can. So we don't call that perimeter when we have a circle. We call that circumference. Times the height plus the area of the 2 bases. Notice it's a capital B again, meaning area of. So look here carefully. You notice we're talking about surface area of prisms and cylinders, and they're related. It's perimeter times height plus 2 bases. Perimeter times height plus 2 bases. It's the exact same equation, except in a cylinder, the perimeter, we call that circumference. So that's one less thing to memorize, is perimeter times height plus 2 bases. This is surface area of a prism and a cylinder. Now, pyramids and cones, super important. This gets a little tricky. A little tricky. Watch very carefully. Okay, here's a net of a pyramid. Okay, we're going to fold this net back in. And I'm going to squiggle. Watch, do you notice that says the word slant height? You're going to see where that squiggle goes in just a moment. So if we draw this back in, there's the dot. Dot, now you connect the corners. The front 2 are solid. Solid, this back is dotted. Kind of, there you go. And technically, this back should be dotted. There you go. Now, that's the height of the triangle is what's called the slant height of the pyramid. It is the height of the pyramid going down sideways. Super important. It's not the internal height of the pyramid. That's called the slant height. We use an L for slant height. What's called the true height or the altitude goes straight down the middle and smacks it at a right angle. That's the true height. When you're dealing with volume, you use the true height. When you're dealing with area, you use the slant height. Volume's inside, slant height's outside. So if I want to find the area of these triangles here, it would simply be, right? It'd be base, lowercase b, times height over 2. And if you do all 4 bases, when we trace that, that's actually the perimeter again. Perimeter. So we start with perimeter again, but this time we're doing slant height, and because these are triangles, it's over 2. Perimeter times slant height over 2. Now you only have 1 base. Perimeter times slant height over 2. That gets you the area of this image. Now, once again, Esther, if these equations confuse you, chuck it. Instead, just find the equation, find the area of this separately from that, separately from that, separately from that, and this, and just add it all up. These equations I'm giving you are shortcuts. A cone looks like this is a net, so when you draw it, it looks like this and solid on one side. And in this case, your slant height is down the edge of the cone. Your true height would be down the middle. We use an H for the true height or altitude. We use an L for the outer slant height. And this has the same rule as the other one. Instead of perimeter, we don't call that perimeter. We call it circumference. So it's circumference times slant height over 2 plus the area of 1 base. So just to recap, the surface area of a prism is perimeter of the base times height plus the area of 2 bases. A cylinder, circumference of a base times height plus the area of 2 bases. Pyramid, perimeter of the base times slant height over 2 plus 1 base. And cylinder, circumference times slant height plus 1 base. Okay, that's a lot of material, Esther. A ton. Like I said, in my regular class, I teach what I just taught you in literally three different classes. So I hope you're not totally confused right now. I'm doing the best I can. If you need to, take a break. Now I'm going to finally get to some examples. We are going to find the volume and the surface area of each solid. We're going to follow these steps. Shade, trace, perimeter, base, equations. Circle, plug, chug. 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 Hopefully you started chanting, because if you follow these steps, you'll never get lost. I promise you. One more time. Shade, trace, perimeter, base, equations. Circle, plug, chug. I'm going to walk you through these steps. Ready? Step 1. Simply shade your bases. Get your brain to identify what your bases are. Lightly shade. Shade your bases. Now, trace your base. Shade, trace. Perimeter. So now we're going to start finding the perimeter of this. And since it's a circle, we don't call it perimeter, we call it circumference. We're going to write our equation, C equals D pi. C, D pi, I, C, D pi. So right here, our diameter, we trace it across. So our diameter is not 4, our diameter is 8. Pi. We check for units. There's no units, so I'm just going to write the generic units. It's not squared because it's perimeter, which is one dimension. Got it? Okay. We shaded. We traced. We did our perimeter. Now we find the area of our base. So lightly shade, again, one base. And we're going to use capital B here. That means area of, and that's a circle. So we're going to use pi r squared. So that's 4 squared times pi. So we have 16 pi units squared. Shade, trace, perimeter, base. Now we're going to do our two equations. Volume equals base times height. And height here is the distance between the bases, so that's 12. Surface area equals circumference times height plus the area of two bases. Now you just slowly plug stuff in. You already have most of it done. Watch carefully. You already have your base. You figured it out right there. 16 pi. So we're going to go like this. We're going to go 16 pi times our height, which is 12. You could do that longhand in the margin, or if you want to get a calculator, I'll let you cheat and get a calculator. Although we shouldn't need one, but you can go ahead and get one. So we just found our volume. Our volume is 192 pi, and volume's 3 dimensions, so it's going to be units cubed. That is volume. Okay, ready? Now we're going to do surface area. Surface area. We already have our circumference. We found it up here, so it's 8 pi. So we do 8 pi times your height, which is 12. Plus the area of two bases. And we already did our bases earlier. They're 16 pi each base. Now you simply, I'm going to do 8 times 12. 106. Excuse me, that's 96. So we have here 96 pi. Plus, that's 32 pi, and you simply add it up. So our surface area, I'm going to use the abbreviation SA, is going to be 128 pi units squared. Area is 2 dimensions. Therefore, it's squared units. Volume is 3. Therefore, it's cubed units. Area is 2. Therefore, it's squared units. Shade, trace, perimeter, base, equations. Circle, plug, chug. Let's try this again. I know this is a lot of information. You're doing really good. All right, shade, trace, perimeter, base. So we start by shading our bases. Remember CPR, two of them, they're congruent, parallel, connected by rectangles. Congruent, parallel, connected by nothing but rectangles. So those two yellow triangles are connected by three rectangles. They're congruent and they're parallel. So shade, trace. Go like this. Shade, trace, perimeter, base. So now we have to find the perimeter. There's a little bit of a glitch here though. Not really a bad glitch, but a little bit. There's 3, 4, and wait a minute, there's something missing there for our perimeter. So we're going to put a little X. This is a right triangle. Forgot to put the little right angle there, but there's a right triangle there. So we're going to go 3 squared plus 4 squared equals unknown squared. You add these two up, that's 9 and 16. Which means that's 25 equals unknown squared. Square root, our little x there is going to be 5. So my perimeter is 3 plus 4 plus 5. 3 plus 4 is 7 plus 5 is 12. So I just found the perimeter of my base, which is 12 units. The area of my base. My area is going to be leg times leg over 2. It's a right triangle, so that's 3 times 4 over 2. That's 12 over 2, so it's 6 units squared. Shade, trace, perimeter, base, equations. Circle, plug, chug. So our volume equation here is base times height. Our surface area equation is perimeter times height plus 2 of the bases. Let's do volume first. Volume's easier. We already have our base. That's 6. So I have 6. The height here is the distance between the bases. Height is not always vertical. Height is distance between the bases. So our height here is 6. So our volume is simply 36 units cubed. Ta-da! That was easy. Your surface area, if you had wrapping paper around it, first you find your perimeter, which is 12, times your height, which in this case is 6, plus 2 of the bases, which is 2 times 6. Let's clean this up just a little bit. This is going to be 72 plus 12. Therefore, my surface area equals 84 units squared. Volume is units cubed, area, units squared. Shade, trace, perimeter, base, equations. Circle, plug, chug. When I mean by circle, plug, chug, I mean to circle the stuff like this. I didn't really explain that. Circle it and plug it in. And chug is my euphemism for get it done. Shade, trace, perimeter, base, equations. Circle, plug, chug. Shade, trace, perimeter, base, equations. Circle, plug, chug. We have 2 bases here. Let's shade them. We've shaded our base. Shade, trace. Trace the perimeter. Shade, trace, perimeter, base. My perimeter here is really easy. We just see that hatch mark. That means it's 7 plus 7 plus 7 plus 7. We don't even need an equation for that. That's 28 units. Our base, of course, is the area of a square, which is 7 times 7. So that's going to be 49 units squared. Shade, trace, perimeter, base. Equations. So volume is base times height. Our base here, we already have it. It's 49. Times our height, which is the distance between the bases. So it's going to be 3. So you simply do 49 times 3. And we get the volume equals 147 units cubed. Perimeter, circle, plug, chug. I circle that, I plug it in, I get 28 times, circle, plug it in, 3 plus 2 times 49. So 28 times 3, it's going to be 84 plus 2 times 49 is 98. So my surface area equals 182. There's no units, so we're just going to write units squared. Shade, base, perimeter, shade, trace, perimeter, base, equations, circle, plug, chug. Okay, pyramids and cones get a little interesting. Not hard, just a little interesting. Okay, ready? We still start by shading, but this time we only have shade. There's only one base now. And trace. Shade, trace. There should have been hatch marks. Put them in, so that means it's 16. So I find my perimeter. The perimeter of my base is 16 times 4. That's 64 units. And the area of my base, it's a square, so it's 16 squared. That's capital B. Remember, capital B stands for area of is 16 squared. It's 256, I think. I'm going to double check just because it's been a long day. That's 256. And it's unit squared because it's area. Shade, trace, perimeter, base. Now, your equation for volume of a pyramid is the area of the base times the true height, which is inside at a right angle to the base. That's your true height, also known as the altitude. And it's divided by 3. Your surface area is the perimeter, right? Perimeter times the slant height, which is like you're sliding like a ski slope down. Slant height over 2 plus the area of one base. Okay. So this one, we already have your base. Your base is 256 times your true height, which is 24 over 3. I'm going to take the 3 into the 24. That's 8. So I'm doing 256 times 8. And our volume here is going to be 2,048 units cubed, because volume is cubed. All right, now notice for this you need that slantite. So I'm going to pull it out so you can see it here. You need that squiggle. So right there, this is 24. This is the squiggle we need. Right here, it's the same thing. Now watch very carefully. See that yellow? I'm going to connect it. If you have the worksheet in front of you, Esther, I want you to physically trace from here to here. I'm going to give you 10 seconds of silence. I'm going to see if you can't figure out what that yellow length should be. 10 seconds of silence. Did you say 8, my dear? I hope you did, because right here, that's half of the 16, which is 8. Okay, now you're going to do Pythagorean theorem to get that squiggle. So it's going to be 8 squared plus 24 squared equals unknown squared. Of course, this is 16 plus... No, it's not 16. Excuse me. I'm bad. That's 64. 8 times 8 is 64. Yes, 8 times 8 is 64. I'm a math teacher. I can math today. Plus 24 plus 24 times 24, excuse me. 576 equals x squared. I end up with 640 equals x squared. Now there's 2 ways we can do this. Watch carefully. We're going to square root, and now I'm going to simplify. I'm going to have 64 and 10. And then this is 8 and 8. A 2 and a 5. So the 8 can come out. So I'm going to have right here 8 root 10. That's called exact terms. I'll show you how to get the decimal in just a moment, okay? But your teacher might want that in exact terms. So what I just did gives you the exact terms. Okay, so now we do our perimeter, which we already got up here, 64. So it's going to be 64 times our slant height, which is 8 root 10, over 2, plus the area of one base, which is 256. And we're going to clean this up just a little bit. That's 32. 32 times 8. And there's 2 versions here. This would be called the exact term version, okay? This is 256 root 10 plus 256. If your teacher wants exact terms, that's called exact terms. Now, to get the decimal on your calculator, you simply find the square root of 10 times 256. And then you add 256. And this is called the approximation version. Approximately 1,065.54 units squared. You can see surface area is a bit more involved than volume. Surface area is a bit more involved than volume. We're going to try 2 more of these because I know that's pretty involved. Shade, trace, perimeter, base, equations. Circle, plug, chug. So again, we're assuming this is a square, even though there's no hatch marks. We shade, then we trace the perimeter of the base, shade, trace, perimeter, base. So our perimeter here is 10 plus 10 plus 10 plus 10, which is 40 units. Our base is simply this square, of course. It's 10 times 10, so our base is 100 units squared. Okay, now we write down our volume equation. Our volume equals, of a pyramid, our area of our base times the true height over 3. And our surface area is perimeter of the base times the height, slant height, careful there, slant height over 2 plus 1 base. Let's take a look here. Our base we already have, 100 times, watch out, watch very carefully. This is a tricky one. Let's draw in our true height. 13 is not your true height. 13 is the slant height here. Okay, it's the slant height. It's the one I've been doing with a squiggle. Your true height or your altitude goes straight down. Technically that should be dotted. Right to the middle. That's your true height. Problem is, you don't have it. We're going to call it X. Okay, connect. You can see that that's going to be half of 10. So I'm doing this. I'm doing 5 squared plus unknown squared equals 13 squared. Here's a shortcut. Our unknown squared is going to equal 13 squared minus 5 squared. Unknown squared equals, that's 169 minus 25. Our unknown squared equals 144. Square root, our unknown, which is our true height, is 12. So watch out for those right triangles. So our true height for volume is going to be 100 times 12 over 3. And you just reduce. If you need to, get a decimal, but 3 goes into 12 4 times. So my volume here is simply going to be 400 units cubed. Surface area is perimeter, which I already have, 40 times my slant height, which is 13 over 2 plus 1 base. So you can do, I'm just going to divide this out, make that 20. So this is going to be 20 times 13 is 260 plus 100. So my surface area here is going to equal 360 units squared. Shade, trace, perimeter, base, equations. Circle, plug, chug. Let's do this cone. Shade. I shade the base just lightly. Now I trace the perimeter of my base, which is circumference in this case. So now I find my perimeter, which in a circle it means circumference. C equals d pi. And in this case, my circumference is simply going to be 30 pi. The area of my base is pi r squared, so my radius is 15. So that's 15 squared times pi. 15 times 15 is 225 pi. So there's my circumference, there's my base. Ready. volume of a cone equals base times the true height over 3. Surface area equals circumference times the height over 2 plus 1 base. Ooh, hang on. Correction, that's not true height, that's slant height. Let me keep my variable straight here. Watch very carefully. Your slant height here is 17. Your true height, once again, drop it straight down. You don't have it. This from here to here is 15. So in the margin, you're going to go 15 squared plus x squared equals 17 squared. I'm just going to be quiet for about 30 seconds. I'm going to let you find that x by yourself. You should have gotten your x equals 8 there, Esther. So volume is area of the base. Remember, it's area, so that's the 225 pi times your height, which is 8 over 3. Now, there's two versions of this. There's called the exact terms version and the decimal version. Now, 3 doesn't go into 225. Wait a minute, it does. I apologize. 3 does go into 225. Three does go into 225. 3 goes in there 75. So this is called the exact terms. If it didn't go in evenly, you just leave it as a fraction. So we're going to go 75 times 8. And that's going to be 600 pi units cubed. You can change that into decimal by simply multiplying out by pi, but for simplicity, I'm just going to leave it right there. For our surface area, we're going to do circumference, which is 30 pi, times the slant height, which is 17, over 2 plus 1 base, which is 225 pi. Let me get closer here. 2 goes into 30 15 times, so I'm going to do 15 times 17. So this is going to equal 255 pi plus 225 pi. I'm just going to add that longhand right here. So our final answer for the surface area of this cone is 480 pi units squared. Shade, trace, perimeter, base, equations. Circle, plug, chug. Wow, kiddo, this was a crash course. The last thing you mentioned nets. Nets are very easy. You have to be able to go from a net into a solid and from a solid into a net. So I have several nets here. What I recommend you do is you put your hand flat in front of you and imagine that net like a pattern or a flat piece of paper, and then fold it physically with your hands, imagination, into a solid, and then attempt to draw the solid. Okay? I'd like you to actually pause the video right now and try to draw each of those nets into a solid on your own, and then restart the video to check your work. Take a pause here, Esther. Alrighty, welcome back, Esther. Let's see how you did with these drawings. I know you're a pretty good drawer. I know drawing is something you enjoy doing. So this first one is a cone. And if you were to draw this, it should be solid and then dotted on the back side to represent depth. And then you would have here, your diameter is 30, like this. And then that 52.2 is the slant height, 52.2. So there is your cone solid. This is a square-based pyramid, so it would look something like this. We dot the sides you can't see, so technically you can't see those sides. Put a dot there. That's 19 by 19, and then that 23 is a slant height. It's not a true height. It's a slant height, so it goes down the side there because it's folded slant. This maybe was a little bit trickier. It is, whoops, a little too big. This is a triangular-based pyramid. So this one looks something like this. And then this was 14. 14, that back edge is 9, and then once again that slant height, that's a slant height right there, would go like this, and that is 10.4. This was a triangular-based prism. The easiest way to do this is I start by drawing just the top base. That's 8, that's 15, that's 17. And then you simply drop it down. Then you kind of dot the bottom base because technically you can't see it. Still 17. And then the back spine also cannot be seen. That's called a triangular-based prism. Okay, this was a pentagonal-based prism, pentagonal base. So I'm going to start by drawing kind of a sideways pentagon here to represent depth. Drop it down. Now you draw another pentagon, and these back edges are dotted. This edge was 4. Our apothem was 2.8, and our height here was 5. So you have to be able to go from the solid, fold it flat into a net, and vice versa.